Welcome to Tronless and a short presentation on our innovative PUVI switch and new photonic transistors. Hello! Today I'm excited to introduce you to a scientific breakthrough that has the potential to revolutionize technology as we know it. Our photonic switch technology called the PUVI switch. This innovation is the cornerstone of a new light-speed computing era and holds the key to Tronless's promise to building the next generation of everything. Let's start with the basics. What is a transistor? In short, it's the tiny switch that turns electronic signals on or off. Transistors are the building blocks of all modern electronics, from your smartphone to supercomputers. But the challenge? Traditional transistors rely on electrons to process information, which limits their speed and requires a lot of energy. In fact, the electron transistor has really reached its theoretical limits. We have no choice but to move to a new technology. That's where our PUVI switch comes in. Instead of using electrons, the PUVI switch uses light to control data, allowing us to perform the functions of the transistor at the speed of light. The core innovation here is the use of patented deposition materials that can contort to open and close data paths, creating an efficient on-off switch for light. We call it a light-activated light switch. By leveraging this technology, we're making the leap to a new type of photonic transistors, which are faster, more efficient, and far less power-hungry than their electron-based counterparts. While I won't cover it here, for those that are wondering, yes, we also store data in light for comparable data access speeds, but I'll talk about that in another episode. The Tronless team is not just advancing technology, we're fundamentally redefining it. Over the years, modern computing has relied on core components like Nand Gates, NOR gates, flip-flops, and cabling, and so on. These elements have been the backbone of every device, from smartphones to gaming consoles. But today, we've taken these essential building blocks into the future by redesigning them for photonic computing.
Let's start with NAND gates and NOR gates. These are the logic gates that power modern electronics, making decisions in the binary language of ones and zeros. Traditionally, these gates have relied on electrons to function. But our team has developed and filed patents for photonic versions of these gates, using light instead of electrons. This means data moves at the speed of light, without the bottlenecks and heat generation caused by traditional systems.
We've also filed patents for photonic flip-flops, which are crucial for data storage and memory in computing systems. We've redesigned these too to work with photonic signals, making memory storage faster and more efficient. We've even filed patents on the needed photonic cabling that allows data to travel faster than ever before using light as its medium. With our photonic cabling, we'll create ultra-high-speed data highways that reduce energy consumption while boosting performance. Together, these innovations form the core of our photonic computing infrastructure. The building blocks that once relied on electrons to function have been reimagined for a new era, an era where light does the work. This breakthrough doesn't just mean faster processing. It means less power usage, less heat, and a dramatic reduction in energy consumption across industries. While experts try to figure out how to power AI, Tronless will demonstrate that with a switch to our technology, the world has more than enough power already, meaning this is a huge contribution to carbon reduction from electricity generation. In fact, I'm guessing we have enough renewable energy to power AI right now if our technology was fully ready and deployed.
Of course, none of this would be possible without the brilliant minds behind the technology. Let me introduce you to the key people on our science team. Leading the effort is Dr. Gary PUVI, a world-renowned expert in material science and photonics. He is supported by the smartest man I know, Del Wolverton, a US Navy-trained electronics engineer who specializes in computer electronics. We also have Richard Klein, a mathematician and data center expert. Together, with a team of motivated staff and supporters, they've made the impossible a reality, and we're just getting started.
At Tronless, we like to say we're building the next generation of everything. Why? Because this is not the first time a next generation of everything had to be made. Who remembers the vacuum tube? Once, all our electronic devices operated on vacuum tubes. Then in 1947, the transistor was invented, and it's responsible for the technology we enjoy today. In short, all the devices made with vacuum tubes had to be remade, not to mention all the new stuff the transistor made possible. Now, history will repeat itself as we replace the slow, power-hungry electron transistor with new photonic transistors constructed with our PUVI switches. Because of the PUVI switch and our resulting cold photonic microprocessors, Tronless's processors will power everything from AI and robotics to electric vehicles and blockchain systems. Tronless will usher in a world where devices don't just get faster, they also use less power and create almost no heat. That's what we're creating right now. The future of computing, one light beam at a time. Stay tuned, because the future is brighter than you can imagine.